So, how to Dockerize your Go apps in 2026? First of all, let me give you a brief overview of what this app actually does. So, it's a very simple API. It connects, so the app itself connects to a Postgres database, and then it outputs the users that are in the database. To connect to the database, I'm using the Ent framework. Here it is. So I have this user model which defines what my users table should look like, and then it also generates all the code to interact with this database. And what I also have is Huma. Huma is a package that allows you to create self-documenting APIs. So first of all, to start this app, you need some environment. The environment that this app needs in which it can run is basically just this database. So this Postgres database, and I can start this environment, which is defined in this docker compose.yaml file, by running docker compose up-d, which stands for detached. So it started, and as you can see, it's running in the background. If I go docker ps, then we can see, okay, there are two containers, Postgres 18 and adminer, and then I can go ahead and run the app with go run main.go. And now the app started on port 4200 because this is the default port that I specified in the configuration. I also specified in the configuration the database credentials, and that's pretty much it. And the configuration itself is loaded from this .env file, which is in the root of the project. And now if I go to the browser and if I refresh this page, here I have this, as I mentioned, self-documenting API, or this API documentation, and I have this get users endpoint, which is defined right in my main.go file using this huma.get users, and then we define the DTO that it can accept, and then the response type, which are defined here. So here we have this user DTO, and then we have this user's request, which is empty, so we don't really expect any parameters. And then we have this user's response, which just is an array of users. And here we're getting these users from the database, and we do this, we create this output struct, and we do this mapping and output eventually this user's struct to the API as a response. And now if I send this API request, okay, we don't have any users. If I refresh the page, so this is this adminer interface, which I also defined here, which allows me to access the database and see what's inside. So if I connect to the database, and I can see there are no users at the moment, so I can define one. I can say, let's generate a random ID, and then let's say johndoeexample.com, and then let's say John Doe. Let's capitalize. And then, okay, this user has been inserted, okay. And now if I call the API again, it's delivered to my browser. I can also clone this user and create another one. Let's call Sarah Connor. And here I can also define a random ID. And now I have two users in the API. Now, how to Dockerize this app? So to do that, you just need a Docker file, and I'm going to create one. So Dockerfile. Okay. So in the first stage, we want to build our app. And to build the app, I'm going to use from Golang Alpine 3.23 as builder. I'm going to call it builder, and I'm going to use this base image to build the app in. So to find the base image, you can go to hub.docker.com, and here you can search for, let's say, Golang. And if you go to Golang and if you check its tags, for example, simple tags, you see here, okay, there are lots of tags. What I like to do, I actually go to tags and I search for Alpine, because it's my favorite distribution to run in Docker. It's super simple, it's super lightweight, and here I find the kind of latest tag without tip, because tip is development build, And here we have, for example, Alpine 3.23, and I'm going to use that. And in the next step, you need to define your working directory for the app. So where will it be located inside of this isolated system? So I put it by default to /app, and then I do copy go.mod into this app directory, and then I copy go.sum into this app directory. So it's these two files, and they basically define the dependencies of the app, which I need to then run go mod download, which installs these dependencies into this runner or into this builder stage. And then after I downloaded the dependencies, I can copy the whole content of this project. And after that, I can finally build my app. Now, an important thing to keep in mind here is that we could have actually done it like this. So basically, when we copy everything into the image, then these two files are copied as well with all the other files. So why did we actually copy these files separately? And the reason is that Docker caches the layers. So each line of code here, or each instruction here, is a Docker layer, and they get cached. So basically, when the content of this go.mod file changes, then Docker rebuilds this cache. And then also, when your code of the app changes, then Docker will rebuild this or rerun this instruction next time. And obviously, go.mod and go.sum files, these are the files that don't really change frequently, and because of that, you want to keep them upper in this Docker file. So I'm going to uncomment these, and okay, we finally built our app, and now it's time to define our runner, which is going to be here. So to define our runner, I'm going to use also Alpine from Alpine, and here I'm just going to use the same Alpine distribution that we had, or the same version that we had above, so 3.23, and then I'm going to go and define the same application directory for the sake of consistency. And what I'm going to do next is actually I'm going to copy from builder app/main. So, and I'm going to copy it into this app directory. And then I'm going to cmd and main like this. So what I do here, I just specify the executable of my application. And one last thing that I would like to do, which is not really functional, so it doesn't really do anything, it's just more for documentation purposes. I like to do expose and then the port that my app is running on by default. So if I go to config, here I have this port 4200 defined by default, which my app is running on, and I specified here as well. And finally, I can build this image by running docker buildx build-t, which stands for tag. I'm going to call it go config, and then I specify dot, which stands for just find the Docker file in the current directory. And if I run this, then the app is going to be built. Okay, there are already some cache layers because I tried it before. And here we are. So our app is built. Everything was successful. Now to run this app, we first of all need to make sure again that our environment is running, that our app requires. So we have this database running. And now to run this app, we can do docker run go config. And then the app itself is actually, it starts, but it fails to connect to the database. And it fails to connect to the database, even though the database is actually running. So here we have it running. And to fix that, we need to kind of connect or specify the network of our host. So when you run this image like this, when you start this container, then it's in an isolated environment and it can't really connect to the outside world. No matter what's running on your machine, it can't connect to it. But there's a way around this. If you do network host, then it connects, then it is kind of connected to the network, or it's running in the network of your PC. So if I do it like this, then I think should be able to connect. Okay, failed for user root. So now we're not loading the configuration from the environment file, so I can go and do env file and then .env, and then our server is finally running on 4200. And then if I go back here, if I refresh the page, it's still running, or not still, but it's running again, and this time it's running in Docker, and I should be able to retrieve the users if I do send API request. By the way, if you want to learn more about Huma, about creating self-documenting APIs, connecting them to the database, just leave a comment down below and I make a video about it. So thank you so much for watching. If you enjoyed the video, please hit the like button, leave a comment, and see you next time.